Good morning, good afternoon, good evening, where you are in our virtual world. Today, my name is Ron Dagdag, and I will be talking about developing your inner Spidey Sense, which is all anomaly detection for apps, not just necessarily related. And I'm going to focus more on the Internet of Things application. Feel free to ask in the chat if you have any comments. Uh, I would I can answer them, and will be monitoring them as we go. Uh, Spidey Sense. Anyone you familiar with this character? Most likely, you've seen this in all the reboots and different movies. I think I heard there's a new movie that's coming up that has like all different Spider-Man, uh, I guess previous characters or previous, it's like a Spider-Verse or something like that that had all the old characters or the old movies in one. All right. So what is Spidey Sense? It's a tingling sensation at the back of Peter Parker's skull that tells him if there's any danger or something before it happens. It's always like that moment before it happens. He knows, and it gives him that ability to detect clones or evil. It also gives him that capability to whenever he's impaired or unable to see or hear, he can use his spidey sense to roam around or to to find secret passageways or hidden objects, and of course, to fire his web shooters to target it accordingly. And of course, changing to his costume, I think he uses Spidey sense to make sure nobody's watching him change his clothes, right? Okay, and of course, the real Spidey sense, the real spiders, they have this hyper awareness. Every time you look at a spider and see this long, thin, hairs, it's called trichobothria, and that's their way of reading, like a different sense for them to detect low-level vibrations, through their web. uh, they can actually detect sounds because was how that's how sensitive those hairs are, and in order to detect if there's a prey or be able to eat, right? They can detect small insects moving up to 3 meters away, and I think that's amazing how these spiders evolved that way. And of course, if you're a new web developer, that's how it feels like. You're casting all throughout the world, my website, and there you go. Nothing happens. So any new web developers here, feel free to jump in. And what is Spidey Sense in my definition of it? Or yeah, it's that gut feeling or that vibe that you feel. Yeah, some people say it's like intuition, but as a developer, I kind of, you build this spidey sense. You kind of know when the project's gonna fail, or just, the capabilities of that project, what you need for that project. It's that through time you understand, uh, and the blind spots, and it's what you learned from the past, right? And of course, this is a quote from Julius Caesar, and I believe in that is experience is the teacher of all things. It's that battle scars that we learned through the past to know, how to approach things or how to do it better. Of course, in I call in the computer world, right? There's an IDE, so where you have your higher level programming, and then you have a compiler that would convert it to a low level, to be able to for the computers to understand, right? In our bodies, we have insights, instincts, and intuition. In the human world, insights is your conscious mind deciding the advantages or disadvantages, or of making a decision. And of course, you have that you get all those experience not just uh, through time, but also their instincts and intuition, right? Your instinct would tell you, uh, if you have to dodge, or and also intuition, which is what is considered Spidey sense. All right. Today, our agenda is to talk about anomaly detection, and I'm going to focus on time series anomaly detection. We'll do a little bit of demo, or how we can do anomaly detection, and some takeaways. So anomaly detection is, it's kind of like this, that Spidey sense, right? It's it's identifying unexpected items in your data sets, which is different from the norm. It's it's weird, the weird stuff in your data. It's an outlier. Then the assumptions are these anomalies doesn't happen every time. It happens rarely, and it's different from the normal instance significantly. It's out of the norm. Of course, today, it's out of the norm. We don't usually have conferences. Of course, it's been a year now. Conferences virtually. Most of the time, we meet face to face, and this is out of ordinary. Hopefully, of course, for me, the normal is let's go into the room, let's talk about this technology and attend conferences. But virtual conferences is good enough. Nothing's stopping us from learning, right? So what are the causes of outliers? It could be artificial, or non-natural. Of course, another one is natural. Artificial, so what causes it? Could be a data entry error. When you fat fingered something from 100,000 to a million in your data, yeah, that is a data entry error. Measurement error, it's, maybe the uh, meters versus, uh, you know, or yeah, depending on how you measure it, it could be Celsius versus Fahrenheit, that kind of thing, right? Different unit of measure. Experimental error, it could be, most of your data is the end of a sprint cycle. So that would give you an experimental error. You started late collecting the data. Intentional or outlier, uh, it could be something like, underage reporting alcohol consumption. Of course, they're going to lie. They're not going to say they drink a lot. And data processing error could be extraction errors and how you extract data, and you transfer, your ETLs, right? How do you extract it and you process it? And that could be a problem too. Sampling errors is where your report's supposed to have all the athletes, but you include a lot of basketball players. That would skew. So that would be a sampling error. And of course, natural error is when it's, not artificial. So at the end of the day, what we're trying to do is you have a stream of data, right? That includes the defective ones and the blank ones here. That means it's good data. These are defective data. You pass this here, and you decide, is this data anomalous or not, right? Of course, there are instances where most of most of the time you would detect, that it's not anomalous. And of course, if you detect it, you can identify. But sometimes you can figure out, hey, you weren't able to detect that that's anomalous. That will be part of your good data. In terms of bad data, sometimes you can detect it as defective even though it's not, right? So it depends on the algorithms, or how you train your algorithms, or how you specify those parameters. Of course, I'm not going to focus on this, but one thing you can, measure, right, the effectiveness of your anomaly detection is, using the confusion matrix, where you specify the precision, recall, and accuracy. Of course, that's what also they use to know how COVID vaccines are effective. Using confusion matrix. At the end of the day, here's what we're trying to do. We're trying to find a needle in a haystack. If the needle is that big, yeah, there it is. It's easy to find. But most of the time, it's not as easy. So what are the different methods you would use for anomaly detection? It could be rule-based systems, statistical techniques, or through machine learning. Rule-based system is where you specify the rules, right? A threshold. If the sensor data is this high, send an alert. If it's this low, it's send an alert, or within this range. Other than that, it's good data, right? And of course, rule-based system requires tweaking, and of course, through time, you learn what are the known anomalies, what are known problems of existing systems, of an existing system, or is existing sensors, existing machine, right? So that's when you have the industry experts telling you, okay, what are the parameters for these type of, or what are defects, that kind of thing. A problem with rule-based systems is, it does not adapt as the pattern change through time, right? It does not know. And of course, it does require lots of data labeling. So an expert have to look at the data and figure out which ones are good data and which ones are bad data. And that takes time. Another approach is through statistical techniques. Statistical techniques when you identify the mean, mode, the medians, those kind of things. You can also use rolling averages or moving averages to identify uh, are there anomalies in my data. You know, Whenever you're doing, working with the stock market and you're trying to identify when to buy and when to sell, those kind of things. You use a lot of statistical techniques to be able to figure out, and you can use that in here too, where you have another way is through histogram-based outlier detection. You can do, like moving averages or some filters where you have a Kalman filter type. Sometimes it's easier to use statistical techniques versus machine learning methods because it's easier to explain it to somebody, the formula, and it's more interpretable and useful than machine learning models. So every time you have to decide which one you're going to use to identify anomalies, consider statistical first before you start working with machine learning models. Of course, if we're trying to decide, you know, good data versus bad data, it could be a classification, right? It could be a supervised learning. But when do you use anomaly detection method versus a supervised learning? Like hot dog, not hot dog type, right? When there is a very small number of positive examples, meaning anomalies, it makes sense to use anomaly detection algorithms. On the other hand, if there are a large number of positive and negative examples, almost equal in size, then it makes sense to you to do a supervised learning. When there's a larger number of negative examples, of course, it makes sense to use anomaly detection algorithms. And when there are many different types of anomalies and hard to learn from positive examples, sometimes you haven't kind of understand the whole data, you're trying to figure out the different types, and you haven't discovered everything yet else, it makes sense to use anomaly detection algorithms. In terms of supervised learning, if the positive example is likely to be similar to the training set, it makes sense to use supervised learning. So that's what you have to consider. What is your data that you're training it with be like? If you're training it with something that would be the same with your training data versus what your positive examples are, then it makes sense to use supervised learning. So most likely you'll see anomaly detection through fraud detection, right? Your credit card monitoring most likely would use fraud detection. Most likely you've experiences where you've gone outside the country or gone outside the norm of what you're trying to do, and suddenly your credit card gives you an alert that says you can't use it anymore because it's out of the norm, right? Manufacturing would be a good use case for anomaly detection. You have a machine run constantly, and suddenly there is, out of the ordinary that it would fail. A sensor fails or something on that machine. That would be a good use case for anomaly detection. Monitoring a data center. Most likely they've used that a lot. Of course, Internet of Things is a good application for anomaly detection. Um, Supervised learning is when you have a lot of examples, like email spam classification. Spam out there. They most likely their use, your email. They're using that to identify junk mails based from the training set or data training set. When you specify in your email, hey, that's a spam or not a spam, that kind of thing, they use that to improve their supervised learning. Weather prediction, uh, the reason why is, of course, I live in Texas and sometimes weather is finicky over here. And weather prediction, most likely it's either going to be sunny or rainy or snow, those kind of things. It's already, all the different classifications is already identified. Same as cancer classification, because there's experts on the field that knows all the different classifications of these cancer cells, and it makes sense to use supervised learning compared to anomaly detection. So it kind of gives you idea when to use supervised learning versus anomaly detection. Of course, since I started talking about machine learning methods, there are different ways in how you can use anomaly detection techniques. You can either be supervised, unsupervised, or self-supervised. So I found out when I was doing research about this, I learned more about all the different algorithms. It's not just one algorithm for anomaly detection, but there's a slew of them. There's a bunch. So it just depends on the data set that you have to decide which ones you're going to use. So it's sometimes machine learning models. You can use anomaly detection using density-based in terms of data is when you might be using a k nearest neighbor algorithm where the data points are kind of close to each other, and that's when, if they're outside the norm, that's when you specify, hey, that's an anomaly. Or a cluster based, where you split up the data into different clusters and then identify it. That's when identify that the outliers are anomalies, or where it's far from the centroid. The k-means, most likely you're going to use that. Of course, you can use Gaussian distribution also. You can calculate the Gaussian distribution, and if it's outside of that Gaussian distribution, you can identify that is an anomaly. There's also vector machine anomaly detection. There's where you split the data into half and then identify which side are you on at the end of the day. That's what it's trying to do. And identify anomaly detection that way. There's also PCA-based anomaly detection. What I'm trying to get at is I found out there's different algorithms, and of course it's growing through research and all that. But what I want to focus today is what are the available things that is out there for us developers that we can incorporate to our programs. Internet of Things, of course, it is possible because there's a bunch of data out there that is available. Sensors are becoming cheaper, and that's the reason why you think about your phone, how many sensors that it can collect. And of course, with the improve of networking, the improved data speed, it's easy to send data up to the cloud and be able to do processing. Or not just that, even the CPUs of these machines, or Internet of Things have done greatly to be able to detect and process data more. And of course, even though you have the volume is high, the data speed and processing is high, now the data is moving fast, but failures are not tolerated. So there's different scenarios where these machines have become critical in the process. And of course, whenever something's broken with the streaming data, this is how it feels like. There's figuring out where the problem is. The artificial intelligence of things, like what I was telling you about in terms of insights with the interpreter module and the instincts and intuition. In artificial intelligence of things, you might be thinking about, where do you process the anomaly detection? Would it be part of the edge gateway, meaning at the edge or closer to the user, closer to the sensors, right? The real-time devices, where you have the sensors. Would you do your processing of, anomaly detection there? It could also be through the cloud, right? The cloud process where you have your device twins, being able to, that's when you hear about the device twins and processing it as it sends it up to the cloud. You can do your anomaly detection there too. And of course, through insights by having a dashboard or through business intelligence, you can have your anomaly detection on the Power BI, or you can incorporate all those as you show your chart or build the chart. So there are different areas where you might want to incorporate some of these algorithms. Of course, there's different type. I'm gonna focus more on the time series data anomaly types, meaning there's two variables: time and then your data, right? So there's different types: outlier, spike, level, and shift, uh, pattern change, and seasonality. Outlier would look like this. Through time, your machine is running good. The range should be like from between 14 and 16, based from that data set, and then suddenly it spikes up. That tells you, hey, there's an outlier there, and then it goes back down. So now you have to decide: do you send this alert somewhere, or do you keep it and ignore that? Another one is spike and level shift, where it's running at this parameters and suddenly it spikes up into this, and the levels of your values have changed up to a certain value. So you think about it, you know, sales data, right? A specific sales data, and suddenly it went up that way. That's good, but it depends on if you want to alert that, right? Another one is spike and level shift. Uh, is there's that pattern uh, that you can see here, and then of course there's that out of norm pattern. Of course, pattern change, where maybe you have your machine running at a certain speed, and then suddenly it's limited to its cycles. So what happened there? So that might be an anomaly that you have to consider. Seasonal pattern changes could be, the sales of ice cream around certain months, and you have to consider that. The sales of, I've heard pizza uh, is also have seasonalities. So those are the things you have to consider every time you're looking at you know the your data set, and how it relates. So because you can see patterns here, and then this is out of norm. Of course, whenever there's production issues, it's out of being able to detect it earlier, the better, right? And that's how it feels like. When you have streaming data, it's like stopping a train right in the middle of IID data sets. when you have you'll hear this whenever you're talking about time series data. Your data had to be identically distributed, meaning um, there's all the samples are taken from same probability distribution, meaning, you know, what consideration is this roulette? It's the numbers uh, within that cycle or within that wheel, right? And they're all independent events. That means every time you throw the ball, it's a different reading. It's not dependent on the previous reading. So it has to be, your data set has to be independent from each other and then identically distributed. So those are the requirements that you would need to use. Time series anomaly detection can be spikes uh, and change points. What you can detect, that's the easiest one, uh, where you can indicate persistent changes over time and level changes. Let's see. So what we're going to do today, I'm going to do a demo on how you would do ML.NET in edge devices. I will not focus on Azure Stream Analytics. There's also machine learning uh, anomaly detection there. Also, there's an Azure Cognitive Services called Anomaly Detector. I'm going to do a demo on that one. So we'll start with the ML.NET in Edge. So I would recommend, if you want to try out Anomaly, what's it? What you call these, the kiosk. Let's see if I can start it. Yeah, I have a sample here. Let me see if I can run that anomaly detection sample. Okay, maybe it'll. So there's that anomaly detector. So what I want to show here is you have your data set, right? You have your time series data and your data set, and you want to detect anomalies, see if it works. So there's that pattern that it was able to analyze, and then it was able to detect based from that previous data to detect, hey, is the last item on mine anomalous or not? So that could be good for, like, let's say telecom sales, your sales, right? And then suddenly, hey, that's out of ordinary, and it's out of ordinary, and that can be detected as anomalies, as an anomaly. And of course, there's different parameters how you can set, the more the sensitivity you can specify, and it would detect maybe less anomalies. And if you can make higher sensitivity, it would detect more anomalies. And you see this blue is like the range of what it is kind of expecting around that time. Okay, so now that we kind of visualize what's happening on this anomaly detection, let me try to go back to the presentation. Any questions so far? Is about anomaly detection before I focus on some of the demos? Now, feel free to paste them in the chat if you have any questions. ML.NET, if you're not familiar with ML.NET, it's an open source platform, cross-platform ML framework, so that you can deploy in the cloud, in Azure, or on premises. It's built for developers that have C# skills, F# skills, that wants to integrate machine learning into their .NET application and does not have data science or any machine learning experience. It's not required. So ML.NET has time series catalog that you can incorporate into your application. They have all these different algorithms or different at the end of the day, API calls, right? That you can just incorporate to your application. I'm going to focus today on this detect IID spike, where if there's a change, if there are changes in the algorithm, or it would predict spikes instead of change points. All right, let's try to do a demo real quick on here. Okay, so I have my data set, this CSV file. Uh, I have the timestamp and then my Raspberry Pi data, right? So so as it goes through, the common values is between a certain 29, 22, 31, and then at the bottom I kind of tricked it to where it's higher values. So this would determine, hey, that value is anomalous, right? It's out of the ordinary. So just looking at these values right here. So to make it out of the ordinary, because most of the time it's 20, 26. So here, in order to use ML.NET, one thing you have to consider is you have to there's a NuGet packages called Microsoft.ml. And if you want the time series data catalog, there's a Microsoft.ml time series that you can add to your program, to your .NET program, and then you can use that add that using Microsoft.ml and Microsoft.ml.data. So what I'm doing here is I want to read my CSV file and put them in an object. So this is my initial data, trying to read the columns from my CSV file. And here's another one, because I want to, at the end of the day, what I want to do is to get the temperature and humidity and calculate that. I have these on my GitHub page, so I will send the link later on. But what I'm trying to do here is read that CSV file, okay? And in order to use machine learning ML.NET, you have to use this ML context. This ML context gives you that capability to use all the different catalogs, right? All the different API calls, or not just API calls, the library calls that you can like ML context, that data, anything related to loading the data, you would use here. So now I have a data view. Once I have the data view, I can create the pipeline. There's that. So the pipeline here, what I'm trying to build is I want the temperature data to be converted into, see if I can show you that really, into, instead of a string, converted to a double or a number. So here I would convert the temperature data from string to single, and then the humidity to single. And then there's always that formula. There's always that fit and then transform that you have to call. You fit the data and create a transformer, and then from that transformer you can transform the data into the result. So this detect spike is the one that would run and call and create another pipeline for me. The good thing about this is the anomaly detector does not require training data. Your training data is the previous, you pass in the last 5 items or last 10 items to your data set, and then it will process and learn from that. So like in here, I'm specifying, I want to use this detect IID spike. I want to read the column temperature based on my data set, on that data view, and I want to specify the output column name and as my prediction. And then I have to specify the confidence, and then this p-value history length means it looks at the last 25 items on my CSV files, right? So I'm detecting the last item, and the last 25 items would determine if the latest item that I'm checking is anomalous or not. And then the confidence level, remember when we were when we were specifying here the sensitivity, you specify 95. So that's so it can detect more or less. So it requires a little bit of tweaking here and there. But the good thing about this is it's just it's just a calling this method, and it's good to go in specifying the data. So training the model, it does not require you to have any previous data. So that's why you create an empty data view, you pass it to this fit, and then of course there's the transform part where you pass in your data set, and then it will give you the uh, the results of your prediction. So after I run that, or I can run it again if you want to, it would read this CSV file, and as it runs, every time it would process data, right? So it goes through each one of these and pass it to the algorithm. It looks at the last 25 items to determine if this is anomalous. You see this 0.26, that means it's not anomalous because 95% confidence, meaning 0.05 as has to be the value here. So it's like the inverse of it. So before it became, it goes here. So here it looks at the last 25 items. It determined this item is anomalous. And of course, this one too. It looks at the last 25 items. It figured out that is anomalous because it's the result of the probability is 0.02, 0.03. This one is 0.06, so it was not able to determine that is anomalous. And this one, it was not able to determine because it's because our confidence is 95% level. If it's 90% level, most likely this one would be considered anomalous. But it's only looking at the last 25 items. So that's why maybe it figured out, hey, it became normal here, so it has that contribution that it figured out that is anomalous or that is not anomalous, those kind of things. Does that make sense? Yeah. So it requires a little bit of tweaking, identifying in terms of your data set what is considered an anomaly or not, based from the previous data. Cool. So that's how I'm displaying here the prediction. If it's you know if it's anomalous, it will give me that prediction is to 1 and spike is detected. Okay. All right, let's go back to the presentation. Guys, let me know if you have any questions, if this is if you need some clarification. All right. Of course, there's a new version of the time series catalog where you can identify seasonality now, and also anomaly detection for removing seasonalities too. Azure Stream Analytics is where you have you ingest your data, you send it through either Azure Blob Storage or Event Hubs. You send it through Azure Streaming Analytics, and there's a way you can call to detect anomaly detection there, and then you can send alerts based from that. So here's one example of how you would detect spike and dips. If you're not familiar with, I think is it MuSQL in Azure Streaming Analytics? So it's kind of like SQL. Uh, you have your input data based on the data you're getting. The critical part here is there's a function or there's a method that you can call where you specify, okay, 95% confidence, look at the last 120 seconds of the data that I receive from Stream Analytics, and base that my formula or detect anomalies from the last 120 seconds of the data that I received. And then you can specify, hey, that's anomalous or not. And that's how you can get the score here, and also if it's anomaly or not. So that is one way how you would be able to detect that. Another one is through, another change point is another way how you would receive, uh, to look at the last, like in this case, the last 20 minutes, and as my data set, and based from that, as I receive the data, it looks at the last 120 minutes or the last 20 minutes, and base anomaly detect, base all the values from there, and then identify if if there's a change point value, or if there's like a flag that I can specify. So you can get values from a from temperature data to IoT hub, and based from the IoT hub, you can send it to Stream Analytics, and then you have those real-time scoring and deliver it to, let's say, a blob storage, or an alert system, or an Azure function. That is one way you can use inside Stream Analytics. Like what I said, I don't have enough time to demo the Stream Analytics side. If you want to learn more, there's good documentation about the Stream Analytics. Cognitive services, I find, is the easiest way to, if you want to use these anomaly detector. So Azure Cognitive Services does not require you any machine learning expertise. And at the end of the day, it's just an API call, and the API is this anomaly detector. So the idea here is it's just a RESTful API, does not require us any machine learning expertise, like tweaking some of the values, in which I did demo a part of these kiosk. This one is actually using anomaly detector and calling the API as it passes through to detect anomalies. So each one of the run is a call to the API, and on the fly, it actually creates and figures out the algorithms for you that you would need to detect the anomalies. And it's being used. So you can easily use it. You can actually have it as a batch, or as they occur in real time. So I'm going to demo that. But the way it's doing it, I found out, is it's using this different gallery of algorithms to determine on the fly what type of anomaly detection it's going to use. It can be either Fourier transform. If you ask me about all these algorithms, I don't know how to implement those. But anomaly detector helps me with that without knowing a lot of the different algorithms. If it automatically figures out if your data has seasonality or without seasonality, or with it, if it needs fine granularity. So that's how it's helping me reduce complexity. So let's talk about anomaly detector. Okay, so what I have here is I have a, let me see if I can get to my video here. I have a Raspberry Pi right there, and here's the code that I'm using on this Raspberry Pi. I installed .NET 5. I installed Jupyter Lab. There's .NET Interactive to be able to run and call .NET inside the Jupyter notebook, and be able to execute commands. So instead of running my program, I mean, I can run it in a console app or however, but I wanted to run it in this browser and be able to control from the browser to to that machine over here remotely, and of course get the data. So like if I want to here, I'm using, if I want to change the color of my matrix or the this Raspberry Pi, if I want to change it to blue, I can change it to blue, that kind of thing. So change it to black too. Okay, so I'm gonna make this larger a little bit. So what I'm doing here is I'm reading the temperature data from my Raspberry Pi. It has a Sense hat on top of it, and based on that reading, I would add it to these. So this one is using asynchronous streams. As I read the data, wait for about a minute, and after a minute, read it again, spit out the data. And so what I wanted to do is, as I read the data, right? You have your for each, read the temperature, or I would like to round up the time to the nearest minute and then add it to my list of temperatures. I have a tuple that is a pair of date and value. As it goes through, at the end of the day, what I already run this application, I have my temperature reading at this point in time with this value, temperature reading at this point in time, this value, and it would be list of items, right? And it would be in that list. And so after I run it, I will have a list of data, and this one I want to get a NuGet package called Azure Cognitive Services Anomaly Detector. This allows me to be able to connect to Anomaly Detector API, right? And these ones are some of the how you would use the library. Use or there's you include Azure.cognitive services, that anomaly detector, and of course the models, and of course be able to call these get series. Here what I want to do is to build the REST call, right? And in order to get the REST call is I pass in that list, and that list I add it to this request, because anomaly API anomaly detector requires me to pass the the last my data set, and I specify, okay, this data set, it has it's time series data with minutely. So that means the data between those is per minute, per 1 minute. And here I want to detect based from this data, I call it the last detect async, and pass in the request, and it would calculate if that item or the last on my list, the last item on my list, is it anomalous or not. So that's what it's trying to do. This one calls the API, and the API would return me if based from the request that I sent, that I built here, based on my data set, is my last item anomalous or not. In order to spin up um, Anomaly Detector, you have to go through Azure Portal. You have to create an instance of Anomaly Detector in Azure Portal, and then get two things, right? You need to get your endpoint and the subscription key. There's a link here how to create that Anomaly Detector. It's easy. So what I'm just going to focus on, at the end of the day, we have the subscription key and then the endpoint. So once you have that, you can pass it to the when you create this Anomaly Detector client, specify the key, and the endpoint as part of creating that instance of Anomaly Detector client. And then based on that, I can call that, that Anomaly Detector client and pass in the data set. So what I did here, okay, is here's my data set. I'm displaying them. And at the last, because I want to trick it, where the last item on my list, I specify and I want to force it to where the last item is out of the norm, ordinary. So I specify, okay, last item, make that 200, and then pass it to the client, Anomaly Detector client, create the request, and it will give me, if it is anomalous, I would change the sense hat, or my Raspberry Pi, I would change that color to red. And of course, if it's not anomalous, it won't. So let me see if it'll run. There you go. It turned red because the last item, the last 25 items, I pass all my data set, or the last items, the last item on my list is 200. The common numbers are these, and then of course it was able to detect, hey, that last item is anomalous, change the LED matrix to red, signifying an alert. Cool. Of course, that that screen is too bright, so I wanted to change it and kind of dim it and change it to black. so I saved my eyesight. All right, isn't that cool? So what? Let me summarize what happened and what I demoed today. I did demo that you can use, the different anomaly detector algorithms, right? There's an API called Anomaly Detector, cognitive services that you can call to, just like a REST API call. There is, Azure Stream Analytics. There is a command in uh, in Azure Stream Analytics to have anomaly detection included into to detecting your streams, and also there is in ML.net that you can use anomaly detector. So where can you use anomaly detector? Right, you can use it into your C sharp, which I demoed today. You can actually have it in JavaScript. There's a Python library that you can incorporate. You can actually have it inside a Docker container. You can incorporate it to Power BI. Anomaly detector can be incorporated to Power BI and also Databricks. So if you have a dashboard, there's a way you can call anomaly detector using Power BI. Of course, if you're doing a lot of streaming data in Databricks, there's also a way you can do that too. So at the end of the day, the best superpower you can give to any IoT project is what we call a Spidey Sense. It's the detecting issues before it happens. If you're interested in learning more about or getting part of my presentation, here's a bit.ly link, or there's a QR code. And if you're interested in learning more or contacting me, my name is Ron Dagdag. I'm a lead software engineer at Spacee. I'm a fourth year Microsoft MVP. If you're interested in contact me, the best way to contact me is through LinkedIn, Twitter, email. And I appreciate your time geeking out with me about Spidey senses, about anomaly detection, about Internet of Things. And now that you got bitten off by these spider, feel free to try it out. I would recommend Anomaly Detector and ML.net, especially if you're a C# developer, to incorporate anomaly detection into your application. Thank you very much. If there are any other questions, feel free to place them in the chat or unmute. And I'll be hanging out for a few minutes. Thank you.